Hey y'all, in this lesson, we're going to learn how to write numbers in expanded form and how to add numbers in expanded form. You might also recognize this as scientific notation. The Hindu-Arabic numeration system is the most advanced system, and it uses positional values, basically. So we focus on place value. When I say Hindu-Arabic, it sounds foreign, but it's actually the numbers you see and use today. So you can consider it your native language in numbers. So the place value is referring to the digits, and it also uses powers of 10. So the Hindu-Arabic number system is a base 10 number system. There are different bases. We won't talk about those today, but we're talking about base 10. And these powers are referring to exponents. And so by definition, an exponent is the number of times something is multiplied. You're going to recognize it written something like this, where A is the base and N is the exponent. In the case of base 10 numbers, the base of every place value is 10. And I have a little diagram down here of place value, and I have it written out as powers of 10 so you can see what I'm talking about here. 10 to the 0, anything to the 0, but 10 to the 0 is 1. So this is referring to the ones position. 10 to the first is the tens position, hundreds, and so on. And then if we go on the decimal side of this number, we have the tenths with a TH, hundredths with a TH, and so on. 0.1, 0.01, 0.001. So that's just kind of a review of place value of digits. So let's go up here. We're going to use that to help us rewrite numbers in expanded form. That E got a little weird. Using place value to express each digit separately. So you're going to want to focus on, when you're looking at expanded form or scientific notation, you're going to want to focus on, it's not really technically scientific notation, but it kind of relates to that if you've done scientific notation. You're looking at each digit as a place value. So 4 is in the ones position, 5 is in the tens, 3 is in the hundreds, 9 is in the thousands. And if you read this number out loud, 9,354, you're actually saying the place value as you read it. So you're going to use that to rewrite it in expanded form. It's 9,000, which can be rewritten as 9 times 10 to the third. 10 to the third refers to thousands because it has 3 zeros, which is also the exponent on the base. Plus 300, which is 3 times 10 squared, because 10 squared is 100, plus 50, 5 times 10 to the first, and 4. This is in the ones position, so we have a 0 exponent. And you can see that we start with the largest exponent and we work our way down in descending order, all the way down to 0. Remember, anything to the 0 is 1. So we actually have 4 times 1, which is 4. 5 times 10, which is 50. 3 times 100, which is 300, and so on. So use that to rewrite these numbers in expanded form. Pause the video, try it, and come back. Go ahead and check your work with the solutions I have on the page. Something I want to point out before we move on is if you're struggling with knowing where to start as far as the exponents, a little hint is the exponent correlates with the number of digits behind the number you're focused on. So if you're focused on the 1 here, there's 3 digits behind it. So we do third power, 1,000, and then 800 has 2 digits behind it, 0 has 1 digit behind it, and 7 has no digits behind it. Pretty cool. So let's use that to go the other direction. We have expanded form, and now we're going to rewrite these in simplified version. So knowing how to go the other way, pause this, try it, and come back. So you could probably write these pretty quickly. You can see that it goes in descending order, so you could just rewrite these first numbers in order. But to know exactly where that's coming from, I wrote these out as separate numbers being added. So 3 times 10 to the 5th is 300,000. 7 times 10 to the 4th is 70,000, 4,245, right? And we're adding all of these. So if we were to add all of these together, we would end up with this final answer. So that's where that's coming from. And then the next one, same process, we would have 4,187. If you wanted to just make sure and add it out all out, we have 4,000 plus 100 plus 80 plus 7. And that's where our final answer comes from. We can use expanded form to show how addition works. And to do this, we're going to use the distributive property. I had a little typo in my notes, so I had to fix it right here. These were plus signs. They're actually supposed to be multiplication. But we have B times A plus C times A. And then if we use factoring, which is kind of like reverse distributive property, they both share an A. And so we can pull that outside. And basically this is referring to, we're using this because it's referring to those powers of 10. So when two numbers are being added together and they both share the same power of 10, we can pull that power of 10 out and add the two digits. Let me show you what I'm talking about. If I have a simple addition problem like this, you might have learned, there's several ways you can learn addition, but one of the ways is by lining up the digits and adding them straight down. And then if there's an overage, I guess, you carry it over. So on here, we do 4 plus 5, no carrying, and then 6 plus 2, and we get 89. Now, where that's coming from, we know, oh, we just line up the digits perfectly and it's supposed to come out the right way. But what's happening behind the scenes is you're using place value. You're using expanded form and distributive method. So we have 2 times 10 to the first plus 4 times 10 to the 0. That's expanded form. And then 6 times 10 to the first plus 5 times 10 to the 0. Now this is where the distributive property comes into play. We're adding these two, well actually, sorry, let me start on the right side. We're adding these two, and since they both share a 10 to the 0, we pull that outside and we add B and C. So this represents A from our distributive property, and these represent B and C. So 4 plus 5 is 9. Then we go to the next set of parentheses. They share 10 to the first. That's our A value. And then we can add B and C. And that ends up, if we were to simplify it, to be 80 plus 9, which is 89. Now the next one, we are going to do a little bit of carrying. So we know that if we were to add this old school style, traditional style, 8 plus 3 is 11, carry the 1. 7 plus 4 is 11, plus 1 is 12, carry the 1 over one more value, and we get 121. So let's look at this in expanded form to see how that translates. We've got 7 times 10 to the first, plus 3 times 10 to the 0, plus 4 times 10 to the first, plus 8 times 10 to the 0. And we get 11 times 10 to the 0 and 11 times 10 to the first. Now the issue here is if we were to add these two, rewrite these in simplified form, we've got a 2-digit number here, which raises an issue. We want this to be a 1-digit number if we're going to write it like this. So we end up kind of carrying it over. There's an extra, an overage that we need to carry over. So this actually becomes 1 times 10 to the 0. We're going to carry this one over. This becomes 12 times 10 to the first, sorry. Again, we have to carry. This one gets carried to the next set of parentheses. And that gives us our 121. That's all I have for addition in expanded form and writing numbers in expanded form. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help. See you in the next one.